Hello and welcome back to another episode of the Oxford MAT Livestream. My name's James and today we've got logarithms on the stream. It's basically my favourite topic. Hello to people who are joining in Slido chat. I've seen Zeki, Rosie, Kay, Anonymous Person and Crunchy Nut. Which is just a good reminder that you can be anonymous in Slido chat. You can put your name if you want to, but we have no way of knowing whether it is your name or just your favourite sort of biscuit. Good to see Anonymous is having a 5-star day. It is way too hot. I am sorry for the building work noises, but I've had to open the windows. I normally have the windows closed for the live stream, but I think actually boil. And rather than live streaming me boiling, I thought maybe we'll just deal with a little bit of building site noise. And they're putting an entire new Department for Humanities together right outside my office window. And they've been doing it for a couple of years. I think they're on the finishing touches now. They're just sort of filling it with books and putting lots of landscaping around the outside. The books are quiet, the landscaping is loud. We're doing the How Was Your Day poll, which is going, not great so far. There's a lot of 3 and 2 in there, more than we normally see. I'm sorry if you're having a 2-star day. That's pretty bad. If you want to let us know why you're having a 2-star day, you can post in chat if you like. But hi to everyone. Who else has turned up? I've seen in chat Jacob and Ruben and Evie and Grace. 2 more anonymous people. And yes, anonymous. But they've set their username to anonymous, which is like pseudo-anonymous, right? Or like they're anonymous, but they've gone to the effort of telling me that they're anonymous. Suspicious. Right. Hello to anybody who's here following the unique summer school that we had this week. Nice to meet lots of people there. Or if anybody's joining from the open days last week, if you were at an open day last week and couldn't join because you're on your way home from the open day and now you're joining live, wow. Welcome to the Oxford MAT Livestream. You've joined on a good moment because the weather's good and I've got loads of logarithms to talk about, so I'm having fun. Right, people have picked up the day poll. It's going a little bit better in there. We will see. Hi to Mary and Will. Let's just pause the vote. Will's asked a question about the MAT format. Mary wants to promote a particular sort of biscuits. Let us know in Slido chat what your favourite sort of biscuits are, if you like. If you don't have to. Will wants to know about writing on the mat in the new computer format. And the answer is that there are 25 multiple choice questions and then 2 long questions. We've got some examples from 2024, but I'm saving them. You can go and look at them now if you like. But we've got some examples from 2024 and there's a practice test which uses older questions slightly reformatted for the typed answer thing. But you're expected to type using a standard keyboard because that's what you get. We're not expecting you to type maths working out. I guess you've got numbers and brackets and things, and last year we used numbers and brackets and equal signs a bit, but not the point of those questions is that it's a chance for you to explain why. So we've written questions where you can which you can answer with those text boxes. Right, with the interview, do I need an iPad or tablet? There's an option. What am I supposed to say to this? No. That's what I'm supposed to say to this, because you don't. There's some. If you can join in by writing on a screen during an interview, I've got something for that. But we also have options for. Maybe I do all the writing, or maybe you write on a bit of paper and show it to the camera. There we go. Oh my god, loads of questions coming in. It's good. Maybe this is the follow-up from the open day. The anonymous mouse, which is a bit like being anonymous, but anonymous mouse. Let's scroll that. Sorry. Does Oxford have an equivalent to the winter pool that Cambridge has? Haha! I love this question so much. I got it a bit at the open day as well. Cambridge have this thing called a winter pool, where some of the candidates who haven't been made an offer are considered by everyone. Oxford has everyone. All of the candidates are in a shared database, so everyone is in winter pool. We don't call it that. Everyone is just in our shared database all the time. So we have a big meeting at the end of our admissions round with all the colleges, and any college can make an offer to anyone, not just with the permission of the the college that's not taken them, but just open season. So we don't have something called a winter pool. We have everyone being visible to all colleges, which part of my job is to make sure that the database runs smoothly. Right, okay. A big bit of Oxford admissions is we do lots of stuff to compare lots of applicants between colleges. For example, interviews, you're almost always interviewed by 2 colleges if you're interviewed at Oxford. But right. Oh, working out. Thank you, Anonymous, who's answered Will's working out question by telling them about erasable whiteboards. There's a little bit more information like that on the tests website, which is here. Test registration is now open. You can go to that website to start registering to take the MAT, which is boring but necessary. Necessary but not sufficient if we're using maths words. And you get some sort of whiteboard to work on. Hello, Lawrence. Okay. How much time should we devote every day to prepare for the MAT? That's up to you, isn't it? I think some people interpret MAT preparation quite narrowly, only looking at the MAT syllabus and only doing past paper questions. And okay, I've designed the MAT Livestream to do that as well. But probably there are other things in your life that are helping you with maths for university, that are helping you with the maths admissions test. If you're doing anything else which is challenging to you and involves mathematical reasoning, then that's probably good for you. I don't know how much of your day you're spending thinking about tricky maths problems. It really depends person to person. Somebody says they struggle with the longer math questions. Well, this is not the best episode today, because normally I would have some longer math questions to look at, but for logarithms, looking at past papers, I've decided to pick out short questions. The way you improve, I suppose, is to not look at the solutions and to take some past questions with those related parts, if it has related parts, and to practice being stuck and trying to think about how you can use the previous idea. You can get those somewhere else. Someone's asked me for the difference between necessary and sufficient. There you go. Let's see. So consider prime numbers. So this is the difference between necessary and sufficient. We're using prime numbers because prime numbers are cool. Consider prime numbers greater than 5. So that's a set of numbers that I might like to try and describe. Then P is an odd number, is a necessary condition for P to be in that set. But not sufficient. So it's got it's necessary. You need to be an odd number in order to get into this exclusive club of prime numbers. It's like necessary that you're odd, but that's not enough. Like they're not letting 9 be a prime number. Let's not get carried away. So you've got to be an odd number and then some. Also, here's an example of the other way around. P is 7 is a sufficient condition. In between me and the building site there is also a public footpath. So we also get background noise of people having a lovely day in the sunshine. That's right, that makes me feel like I'm having a lovely day outside in the sunshine. And I am. Right, P is 7 is a sufficient condition, but not necessary. So someone asked me, do I need to be 7 if I'm going to be a prime number? And the answer is no. That would be enough. If you were 7, that would be a prime number. But that's not necessary. So there's a real difference there, isn't there, between P is 7 is kind of saying too much, and P is odd is kind of saying not enough. And these ideas come up a lot in maths. Yeah, what about 2? So I tried to talk about primes greater than 5 so that I could try and avoid talking about the number 2. I should have thought of a different set of numbers, right? You can come up with your own example, maybe using square numbers or something. I wanted an example where you have some sort of fact that's true about everything in the set and some other stuff. some odd numbers is some large set, and then prime numbers is some small set, and then numbers that are 7 is some sort of smaller set within that. This is a very, very bad Venn diagram with all the parts inside each other. Oh, right, I haven't been looking at chat for ages. What's chat said? I wouldn't say the difference between equivalence and an implication, because neither of my statements is equivalent to being a prime greater than 5. But there you go. What else did I miss? Someone with the username The Better James Monroe. There's just no way to know whether that's their real name or not. Says hi. So hi. Hector says hi. Hector. Should we spend more time on question 1 for the multiple choices? The multiple choice questions form about 70% of the marks, so I think you probably will spend more time on them. But it's up to you. Like if you can rush through them, then that's allowed. There's no time limits for the different sections like that. Some tests have that. What should I talk about in my personal statement? They give you 3 prompts these days. So this year you get 3 prompts, which tells you what they're looking for in your personal statement. You can talk. Maths is always relevant if you're doing some math stuff. How would you sketch the function on the thumbnail? That's a good question. Right. Okay. Yeah. Sorry. I'm now taking psychic damage from people's usernames, which is not something I saw coming. Right, okay. No. That's all right, Grace. I've made a weird example. Let's move on. Okay. Chat. You're still there on my second screen. Some of you are having a lot of fun with that fact. Right, there in my heart. Yes, okay, good fact. Some great stuff's coming through chat. Somebody's just asked why the multiplication power law, that first thing that's on screen, why have I got this disclaimer to say that A should be a positive number? Which is a great question. The answer is because I would like to talk about any real number m and n, and if A is negative, then A to the m isn't defined for negative m. No, maybe you could define it, you could say what you want it to be, but those, it isn't defined for negative, what do I mean? Isn't defined for negative non-integer m. God, that's a mouthful, isn't it? Yeah, it's because I've put real numbers m and n. If I put integers, then we're all okay, I think. Well, I'm still scared. No, I think I'm fine. If I put integers, I think we're all right. Yeah, I'm worried about things like the square root of -1. I don't want to talk about the square root of -1 today. There's no complex numbers involved in the maths admissions test. So if I'm going to set m and n to be real numbers, like 1/2. Yeah, why am I saying negative? Oh, right. Okay, I've really thrown myself. Sorry. Yeah, if I'm gonna talk about m and n being real numbers, like 1/2, then I really don't want to let a be a negative number. Right. I think some of the things I said in the middle there weren't quite necessary. I think I gave you sufficient case to be alarmed, but not all of the cases where you should be alarmed. Hooray. Okay. You can use complex numbers to solve problems if you want to. It's pretty unlikely that you can solve a problem with complex numbers better than just solving it the way that's intended. We do check. Okay, is there a recommendation? And the chat's still going, sorry, chat's still going. Do I think maths harder than Tamura? Yes. Do I think it's worth doing Tamura papers? Yes, probably, if you want to. Yeah, right, yeah. Good. And is there a recommended time to spend on each question? Not really. We had a back of the envelope calculation at the end of last week's live stream, which came out as like, there's 100 marks and 150 minutes. You do the maths, but that's a very rough calculation. Okay. James Monroe has redeemed themselves slightly by saying helpful things in chat. Thank you, James Monroe. Can you use further maths concepts as somebody else? Like complex numbers, they've extended it to further maths concepts. Yeah, it's not going to appear on the web solution that we put up. So if you look at the solutions, quick ad for the Mat Live page, by the way. If you want to get that PDF at the front, partly because maybe you want to scroll ahead, you want to see what it says in the second bullet point, don't you? If you want to scroll down, you can get that on the Matt Live website, which is here, and it's in the YouTube description. And I hope that if you search for Matt Livestream, then it comes up on the internet. It's the page with the same color scheme as this. You can also get a solutions document. So if you want me to get on with just telling you what 2 cubed to the power of 4 is, it's 2 to the 12, welcome to the show, then you could be looking at the solutions doc as well. The solutions doc, like the MAT solutions that we post each year for all or some of the questions, has solutions that use stuff on the syllabus, the kind of intended solution. But if you solve things using other sorts of maths and you follow all the instructions in the question, then you should get marks, and you can get working out marks. I think somebody asked that before. You can get working out marks for like partial credit for these longer questions as well. Okay. Right. And somebody else says, should I be worried about security issues? And the answer is no, you should not be worried about security issues. Okay, good. Right, so let's have a look at these revision notes then. How do I want to do this? I think I'll do this in this mode. There we go. Haha, full screen. Let's go. So I've tried to collect together all of the facts about logarithms, exponentials, and powers that I think you should know. The syllabus says laws of logarithms, and one of the aims of the MAT Livestream is that I clarify what that means, so that if you're studying A-levels and you haven't done logarithms yet, or if you're studying some international qualification and you want to know which laws of logarithms they learn in A-levels, this is supposed to be a list. I have checked this with teachers, see, and against specifications to see that this is what people know. Some of the things though might not be phrased the way that people see them at A-level class. So I just want to highlight this fact about inverse functions. It's just here. I'll put it at the top of the screen and split. That's not an inverse function bit. What am I talking about? In fact, there we go. So this kind of inverse function thing, where we have, I guess, 2 functions. I'm going to rewrite them slightly different. So if you have f of x is a to the x, which is the function that we have sometimes like 2 to the x or 3 to the x or e to the x, somewhere in between. We've got functions like this. And I suppose the idea for logarithms is that we have another function like this, sometimes with brackets written around the x, where the idea is that f of g of x is x and g of f of x is x. So we might even write g as sort of the inverse function of f. I don't totally know how much people learn about inverse functions. I think it varies a bit. Just to clarify for Jonah, yes, I think I said something about partial credit. You can still get full marks if you have a full answer using a different advanced maths technique. That's fine. I was combining together 2 questions. Sorry if that gave a confusing result. Cool. And Kay wants to know about days. When you book a date for the MAT, you will book a date to take it. You don't take it on both days. Those testing dates are going to be offered across the 22nd and 23rd of October this year, 2025. Yeah, so you can sketch graphs of this if you really want to. And Jonah says how they're related. Should we decimal set? Oh, we could decimal set. Decimal set might be more accurate. Let's have a look. I do love decimals. Here's decimals really quickly. Y equals a to the x. Because look, I can have a slider. I don't want a to be 1. That's terrible. Yuck. That's better. 1.25 to the x. Will it do this? It will do this. Good. Okay. So we've got what have I got? I've got a tiny little window down here. Let's make that better. There we go. Okay, decimals. Love decimals. So in red, I've got a to the x, and in green, I've got logarithm base a of x. And there's this fact about inverse functions, which you might have come up against before, that they have this lovely relationship in terms of mirror symmetry. There are reflections in the line y equals x, inverse functions, which sort of makes sense, right? Don't worry about the points where they cross for a moment, but a point over here with coordinates, that's about 25, 14, that means that for the green function, if you put in 25, you get out 14. And for the red function, if I put in 14, I get out 25, because it's an inverse function. It undoes the other one. So if I put in 14, I get 25 for the green one. Put in 25, I get 14 for the red one. Oh, I've said that the wrong way around. For the green one, put in 25, get out 14. For the red one, put in 14, get out 25-ish, up there somewhere. And the relationship there, swapping the coordinates, is a reflection because it swaps x and y, which is like swapping the x and y axes, which is a reflection. Rotation would exchange the axes, but it wouldn't get the directions right. Swapping x and y swaps large x values with large y values, so it behaves like this sort of reflection. You can prove more rigorously, you can prove that it's a reflection, but we're not going to. Okay, good. Yes. Yeah, okay. There are some numbers that you should not put into some of these functions, right? Okay, let's leave it there. Okay, I want my split back. Get my split back. There we go. Where was I? Yes, like they have and chat was ahead of me. Let's quickly record it. It's just disappearing off the end there. Like they have their axes inversed. Yeah, nice. Okay. It's more safe to say, yeah, okay, you want to ban putting in the number 1. Why do you want to ban putting in the number 1? Am I being silly? I think x can be 1. I don't want a to be 1. So if a is the number 1, then I have this problem that 1 to the x is always 1 for x positive, which then is, you can't invert that function. Everything has been sent to the same output. 1 is that flat line that I got in Desbos and said when I saw it. That function doesn't have an inverse. So in particular, log base 1 doesn't make sense. Does Oxford have strong opinions on AEA maths? I have a mild opinion that it used to be more common. Some exam boards stopped offering it in about 2018 or something. So it's not as available as it used to be. But if you've got access to AEA, then I think it's got tricky maths problems on. So I think it fits into my general policy that doing tricky maths problems is good for you, no matter where you found them. If you can't do them, and then you get unstuck and you can do them, then that's good practice for whatever level of maths you're at. It's working for me. I still want to learn maths, and I've got a sort of tricky maths problems that I can't do. I'm stuck on them until I get unstuck. So maybe AEA for you is like that for me. Yeah, right, good. Okay. Right. Okay. Good chat. Let's hide that for now because I want to look at more revision notes. I have labelled this year, just to reassure people, this year I've added in product rule and power rule, the words. Those rules were there before, but we've labelled them this year. That's not because I expect you to know the names for these rules, product rule, power rule. It's because I want to refer to them later in the same document. When I say there's a question on the revision that says use the product rule and the power rule, it's good to have names for things. You're not required to know the power rule by name in MAT. You're allowed to, but it would be not a great question for. I'm looking at revision question 15 in a second, which works within the document, but assumes you know names of things. Okay. And while I'm on things you don't need to know, I've been intentionally vague in the revision notes about how large the number e is, whenever I show this to people and ask for feedback, they say, you can give them more digits of E. It's pretty vague to just say it's about 2.7. But I don't want you to think at home that you need to know more digits of E. Obviously, if you've learnt lots of digits of E, then I'm not saying that's not cool, but I am saying that a math question can't just say what's the 10th decimal digit of E. That's not how the questions work. Good, right, okay. Right, so balancing this balance between like information versus I have to tell you things versus I can't expect you to know them. It's quite weird, really. Like, also, we've put in the fact that E is irrational. I think that's a revision note because I think people are just told that E is irrational in school. I think. Let me know in chat. So I think you learn that E is an irrational number. I hope you learn what that means, but I don't think you learn a proof because the only proofs I know are pretty hard. Grace asks, what's the power rule? Which is a very good question. It's the thing at the top of the screen. Logarithm of a power. I have this product rule as well for the logarithm of a product. Rosie says that learning E is cooler than learning pi, and look, I'm not going to weigh in. As someone who has, at different points in my life, learned too many digits of both of those things, I'm not going to comment. Right, should we do some revision question? Yeah, let's do some revision questions. Okay, we're scrolling. Okay, let's go full screen. So people can see the range of questions that we've got, and let's switch on a vote. Woo! And while we're doing the vote on which questions to do, I'm going to drink some water because this office is so hot, and answer 2 more questions. Are there any books that are helpful for math preparation? What I always say for this, bear with me, is if you take all of the MAT Livestream pages and you print them all out, then you get hundreds of math problems, hundreds of revision problems, math questions with hints. You can put a bulldog clip around it if you like, and it kind of looks a bit like a book if you really squint. That's my recommendation. We could have made this material into some sort of like textbook or something. Instead, we've gone for YouTube videos. I hope that was a good choice. That's what we've done. There are other books out there. I don't recommend any of them. I'm sorry if the authors are watching, but okay. And somebody else says, are you going to be at Unique? Yes, I did Unique this week. I'm doing Unique next week, and I'm doing Unique the week after. From your point of view, Unique is a 1-week experience. From our point of view in the maths faculty, maths department, we're called a department, not a faculty. From our point of view in the maths department, Unique is 3 weeks. We do the same thing 3 times in a row. Sounds like you're the second round. Right, yes. Aha, I printed them all. Unique is a summer school. If you Google, it's got an acronym name that doesn't stand for anything. UNIQ. If you look it up, you'll find out that it's a summer school for UK students. Right, we're voting in chat, and they're voting for large numbers. So I'm going to scroll down a bit so that you can see what they're voting for. They're voting for this sort of thing. Currently, 17's winning. I think 19 won last year. I thought 17 would get votes. And 19 and 16 and 18 in some order. So those last 4 questions, and 15 is kind of the end of the sheet, I think. So we might have a look at 16, 17, 18, 19. Are there any small numbers with lots of votes? 8 and 9, I guess. And then there's a kind of 5% vote for 1 person for some of these. Question 1. Question 1, I should apologise. It just says simplify. I was not expecting you to work out how large these numbers are. They're quite big, aren't they? 2 to the power of 12 is 4096. So, sorry if you've been working out 2 to the power of 12. The solutions doc just says 2 to the 12. Ooh. Okay, as well as being near a public footpath and a building site, we're also quite near RAF Bryce Norton, I think. So that's the experience we're having today. every week with my windows closed. All this sound we're missing out on. Right, good, okay. Somebody else in chat's here. 3rd week. Cool, right, good, okay. Looks like the poll is going 16, 17, 18, 19, and then possibly 15, depending how it goes. Nobody is diverse on their own. Diversity is a property of sets, not a property of people. Look, something's coming on the 3rd week. Cool. Here's an outreach program, including a residential. Does it improve your chances? Well, we sort of hope that it helps you in life generally. It's not linked to applications. We sort of hope that visiting the Maths Institute, and we say, I think for everyone who visits the Maths Institute, sort of hope that it helps you, whatever your life goals are. Plus, I teach loads of number theory on it, so you can learn number theory. Good, okay. What am I going to do? Okay, people are talking about unique in chat. I'm going to let them talk about unique. I'm going to put on the split and go for 16. You can tell that as the office gets hotter, my brain works slower. You can hear me calling out the buttons I've got to click in my software. Split. Yeah. Normally I can get away with that. Right, okay, we've got a question here, haven't we? E to the x plus e to the minus x equals 4, which looks really hard because if this wasn't here for this 2nd term, you would just take a logarithm and everything would be fine. But, oh no, there's 2 of these. You could postpone that problem by saying, well, if e to the x is here and there's sort of another e to the x here, to get u plus 1 over u equals 4, and then work with that equation, you could go and do that. That's allowed. Or you could start handling the equation first. You can see e to the minus x. Let's see if we can get rid of that. If you multiply by e to the x, you get something like this, which maybe you might rearrange to get all the e to the x powers on the left. Either way, you're going to get some sort of quadratic, and if you solve that quadratic, then you'll get some solutions, which you might then want to take the logarithm of. Watch out, because you can only take the logarithm of positive numbers. We've had this a few times already, haven't we, with polynomials and things. Yes, chat is off and away with hidden quadratics. This is the last time we saw this topic, I think, was back in one of the earlier episodes of MAT Livestream, recordings on the MAT Live page, and solutions docs if you don't want to watch the video. This idea that sometimes you can turn it into a quadratic, or spot that this has the same shape as a quadratic. In this case, the solutions are u is 2 plus or minus root. Oh my goodness, what am I doing? Oh, I'm doing that kind of weird quadratic formula. It just sort of happened in front of my eyes. Right, okay, good. Let's do this one more conventionally. Minus b plus or minus the square root of 16 minus 4 lots of 1 is 12 divided by twice a, which is 2 plus or minus root 3. See, if I do the left one, it looks like I've just cheated, but if I do the right one, it looks like I've... To you watching at home, it doesn't look like this. I love hidden quadratics in MAT Live worksheets. I like the idea that we can link this together with the polynomial stuff. Yeah, hidden quadratics. Right, okay, we get these. We should check. It's kind of quite tempting, especially if you have this equation on the right, where I haven't got this substitution. I've just got e to the x. It's quite tempting just to go, okay, then let's just take logarithms. But we should check because logarithm is only defined. Logarithm is only defined for positive inputs. But we're okay. We're okay. 2 minus root 3 is greater than 0 because root 3 is smaller than 2, because 3 is smaller than 4. The square root function is increasing on the positive reals. How many of those words did I need to say? Not sure. That's about 1.7, that's about 2. Looks positive to me. So we're okay. So actually both of these work, and we do get 2 solutions out of this. Yes, root 3 is about 1.7, says Rosie in chat. There you go. Anonymous in chat solved the quadratic by completing the square. Also allowed. Who's going to stop you, right? So you get something like this, right? U minus 2 squared minus 3 equals 0. And that really quickly gives you, I think u is 2 plus or minus root 3. That's really nice. I think I prefer that to the quadratic formula. I have this version of the quadratic formula in my head. I don't know if I recommend learning this because it's another formula to have in your head, but let's put it on the side. Okay, we're going to take a quick move away from logarithms. I'm going to show you this other quadratic formula that's occasionally useful, but I'm not going to say it's always useful. Okay, you have this, right? So you know this quadratic formula, I think. Observation, if b is an even number, then this simplifies a bit, because if b is even, there's a multiple of 4 here, so the 4 would come out of the brackets, this would be even as well, and we're dividing by 2. So if you have ax squared plus 2, I'm going to use a different letter, but in my head it's always b. Then the quadratic formula becomes minus b plus or minus b squared minus ac divided by a, and a is often 1, so this is often a neater formula that kind of cancels the factor of 2 already, because if this thing in the middle is even, then you're always going to get a bit of, I think, well, it depends what a and c are, I suppose, but if they're all whole numbers, then you're going to get a bit of cancellation factors of 2. So when I saw 4 in the middle, I switched to this version. Right, okay, I don't know if that's helpful to anyone. I've seen a 3 blue 1 brown video where there's a third, even more streamlined version of the quadratic formula that I don't quite understand. But there you go. It's come up enough times in my life that I've learned to cancel the 2's. But the hard bit is you see 4 and you have to think 2. Maybe this is bad advice, because maybe this is just going to confuse people between the 2. Yeah, okay, I kind of regret showing you that. Okay, Rosa says nice. What does Alistair say? Alistair says, instead make a graph in your mind. E to the x is just the opposite of e to the minus x. So this function is kind of U-shaped, with 2 as its lowest value at x equals 0. That is true. The graph on the left looks like this. It goes off the bottom of your screen. No, the graph on the left looks like this. It's symmetric. Wow. Because it's e to the x and e to the minus x. So if you swap, if you do the reflection by doing, or a stretch with scale factor -1, if you do the stretch with scale factor -1, which is a reflection in the y-axis, then x changes to minus x, and minus x changes to x, and the value of the function changes not at all, because you were going to add those two things together anyway. So yeah, there you go. So it's a symmetric function, which means that these solutions that we've got, log of 2 plus root 3 and log of 2 minus root 3, those must be plus or minus of each other. It must be the case that if you add them together, you get 0. Because one should be positive and one should be negative at the same distance from the origin. Alistair says that these are roots on either side. Let's check that. So product rule, this is log of 2 plus root 3 times 2 minus root 3, which is 4 difference of 2 squares. 4 take away 3 is 1. So this is log 1, and log 1 really is 0. Good. So it's true fact as well. I think question 17 is about checking that works in general. Yes, question 17, that's the point of question 17. So spoilers, replace the number 2 with n, and all of that still works. So in particular, n here, n squared minus 1 in here, n here, n squared minus 1 in here, And then when you add them up, you get the difference of two squares. Everything simplifies nicely. You get log of 1, which is 0. There you go. So that's question 17. Now that's also why question 17 is there, because, hey, yes. I suppose there's this end of question 16 that I've skipped over, where you're invited to think about how many solutions there are in general, in terms of C. And think about the graph there is really helpful, because you've got this minimum value when x is 0. There has to be a turning point there, or at least a stationary value there, because the graph is symmetric. It can't have some gradient, otherwise if you have some gradient, when you're reflected you have the opposite gradient, so you can't be the same function. So a function that's symmetric in the y-axis has to have 0 derivative at the point where it meets the y-axis. If it has a derivative at all. Okay, there were some requests for, well, we've kind of spoiled 17 now, haven't we? The algebra is slightly weirder with ends around, but oh no, 17 was the question people wanted the most, so I think I will. It won the vote, so let's give it its time in the sunshine. It's with natural logarithms. Why is it symmetric though? Oh, one more go around on the symmetric. Wow. This thing e to the x plus e to the minus x. Its mirror image would be if you swapped x for minus x. So swapping the positive x direction with the negative x direction is what happens when you swap all the x's for minus x. You can do this on any function you like, right? So you're aware of a graph transformation like this, f of minus x is a reflection in the y-axis. But if this is my function f of x, then f of minus x is a bit of a joke, right? F of minus x is this, which is the same thing as f of x. So the mirror image is the same, it's symmetric. In general, if you want to check for symmetry like that, work out f of minus x, and then try really hard to check whether it's the same function, whether it takes all the same values as your original function. So is f of x actually equal to these for all x? Are they equal as functions? If so, well, the word for this is even, but I'm going to say symmetric. I'm going to say mirror symmetric to be a bit more precise. You're an even function. And that's a great moment for my handwriting to do that. Come on, graphics tablet, we can do it. Okay. Good reminder for me that Callie is moderating chat. Come on, Callie, you're doing great. Callie has been asked what was their experience of Matt on the interview. I will give them a moment. And they have also answered the symmetry question. Thank you, Callie, you're doing great. Yeah, right, okay. 18. 18, I saw. 18 is the first step of a really hard question about when a to the b is the same as b to the a for whole numbers a and b. That's a hard question, we're not doing that. But we are doing this x to the y equals y to the x question. What does the question say? It says, use logarithms. Okay, I will use logarithms. I was probably going to anyway, I love logarithms. I've realised I didn't put my base on some of these logarithms up here. Did I get away with this? I forgot to put a base here, and here, and here, and here, and here. Oh, I don't think I got away with it. I don't think I really got away with it. E is my favourite base for logarithms. Sometimes I forget to write the E in, because for me it's almost always E. Right, we're going to use some logarithms. I think I'm going to use logarithms base. Let's make a change. Let's go for logarithms base 10 or something. If I do that, then I get, using the power law, on both sides. I take logarithms of both sides. If these numbers are equal, then their logarithms should be equal. So they're going to be all right. And then I can rearrange it. I think I prefer to divide to get something like So I want a function of x on the left, so I'm going to move all my x stuff on the left, and I'm going to move all my y stuff on the right. And it's not a unique solution because you might have this the other way up, or doubled on both sides, or squared on both sides, or whatever. So the function f is not unique in this thing. But f of x equals f of y. Loads of solutions. So yes, in chat somebody else has got the same thing but upside down, which is obviously fine. And Anonymous says, why don't you just write ln instead of log e? And the embarrassing answer is because at some point in university we all switched from writing ln for the natural logarithm to just writing log with no base. Sorry. In the UK at least, ln is this sort of strange secondary school thing which people use at secondary school and only at secondary school. Outside the secondary school context, and maybe some other contexts I'm not aware of, but outside of secondary school, mathematicians just write log and they put the base on if there's a base, and if there's no base they mean e, which I have feelings about, of course, but there you go. Right. Okay. I should do logarithms based pi, says someone else in chat. That was a good idea. I wish I'd thought of that. Logarithms based pi. Are they good for anything? What can you do with your logarithms based pi? Oh, you know, you got something like pi squared over 6, and you think, the power of pi. I wish I could undo this with my logarithms based pi. Pow. Okay. What are we doing for 18? Oh, we've got this. There's a sort of hard sketch this function. I guess I'm going to sketch this function as sort of, well, I need a logarithm, which is going to be very negative over here. And logarithm grows, but then dividing it by x gives me a very small number for large values of x. How do I know that? Well, think about putting in a million in here. If I put in a million, I'll get into this function. I'll have 6 upstairs and a million downstairs. And if I put in a number like a billion, then I'll get 9 upstairs and I'll get a billion downstairs, which is, a billion is much larger than 9, much larger even than a million compared with 6. This function is very small and decreasing at some point. Does it go positive? Yes, of course it does. It's 0 when I put in the number 1. And then it has some maximum. You are not expected to find the maximum of this graph because you don't know how to differentiate log. Unless you do. If you do, then hey, you could find the maximum of that curve. You could carry on doing this question, which is, this question is taken from the question, taken from a kind of more popular, larger question for which whole numbers is it the case that a to the b is equal to b to the a? That's a much harder question. But you can imagine finding, find some whole numbers like 2 or 3 or 4 or something, such that this thing gives the same values. Why did I choose a base like 10? Like, isn't that a specific case? Well, so I chose base 10 partly to demonstrate free will. You can do whatever you like, so long as you do the same thing to both sides of the equation. So I really could have used logarithms based pi. That's allowed. And I've got down to an answer, so I'm happy. It is a specific number, a specific sort of logarithm, because I've got a base on it. I've got base 10 there. But in some sense, every logarithm is a specific logarithm with a base. So I can't really see a better option. Natural logarithms might have been a more normal choice. Yes, and then because in chat, Eval wants to ask, is the maximum x coordinate e? And the answer is kind of yes if you used natural logarithms, no if you didn't. And that's the point. If you want to do some differentiation or something, that's the point where natural logarithms start to look like the natural choice. Good. Does working out matter in longer questions if you get the answer right? Oh, right, yes. Often that's the question. The question is, if you read them, often to explain why or to show that. And if the question says, show that the sum of these numbers is 10, then you get essentially no credit for writing 10. And if you write nonsense followed by the number 10, you get no credit. The credit for show that it's 10 is all in the showing and explanation, not in the 10. So if you get the right number at the end, that's probably a good sign. But often these questions tell you what the number is, or tell you what the answer is supposed to be, which means that copying it out. Jonah says, why not just always use natural log if you can, since we know how to differentiate it? And that is the attitude that I think almost all mathematicians have taken, to the extent that that one is just called log in university maths. No like base shenanigans, because why would you use any of the other ones? Speaking of, this is what question 19 is all about. I'm glad we've had this chat. This is a good chat, because question 19 is designed for this. It's sort of a derivation of another log law, not one that I think people have reliably learnt as a log law in school, but well, here it is. If you want a log law, we're going to do the steps in the question. So it says simplify this thing. Now hopefully you spotted with laws of these things are multiplied together up here. So it's a case of a to the mn, where really I suppose I'd like to use the fact that that's a to the power of n to the power of m, which was one of the first power laws, the second bullet point in the revision section. So because I've got this product up here, I would like to write this as log a b to the power of k. And the reason I've done it that way around is because a to the power of something log base a cancels out, b to the power of k. That's pretty nice. So Mr. Summer says in chat, at university there will be a time where log with no base will mean the base is e. And they say like in real analysis, and that's kind of the stuff I'm thinking of. That there are lots of research papers that just say log, L-O-G, with no base, and they all mean natural logarithm. Even though secondary school students are being taught ln, that doesn't seem to have caught on with working mathematicians. Harder to pronounce, isn't it? Anyway, maybe that's why. Catchy slogans. Right, next we're asked to look at a to the power of, and then there's this product log a b log b c, but this is a special case of the thing I was just doing, right? So this has got everything in common. The number k is now this log base b of c. So I'll get this, and that works really nicely. So using the previous part with k equals log base c, log base b of c, sorry, we get this, which is just c. That's lovely. So we've got a to the power of this horrible number. So we have a to the power of this horrible number equals c. So x must be log base a of c. Let's write that out in all of its glory, because it's a good fact. And you could stop here if you want a neat looking fact. This number x that we're talking about is this. Isn't that nice? Isn't that nice? It's like a downstairs in the base, there's a b in the base, c, and those b's kind of cancel. Hand wavy, they're not really cancelling, are they? But you end up with log base a of c. The question then rearranges this, and I think relabels some stuff. Possibly a's and b's and c's all seem to be changing roles here, because I've got a version with a's and b's as the bases. I think I want some other stuff. Yes, it's not the same. Why is the previous part? Oh, Yeah, okay. Anonymous has given me some feedback about a question which has made me think. but I'm going to leave it as is for now, I think. Okay. So there's nice facts about logarithms, but the question goes a little bit further. Now, okay, so it wants a fact about similarly. Similarly show that is... So this phrase is a bit of a clue that we're supposed to do something related, like closely related. Maybe swapping all the letters around. Somewhere I've seen problems describe themselves as similarly show that. It's a bit awkward because I wrote that, so now I have to say the person who wrote that probably means, and it's me, so okay, but play along, right? The person who wrote that probably means that we should do something very similar, not a lot of work, but just a bit of work to get a very similar result. Because I can see, right, so this log base a of b statement I'd like is not just divide by that thing. I'd love to divide by that thing to get a fact about log base a of b, but that won't quite match up because the bases don't match over that side, and the bases don't match on that side. Oh, and they're not C in particular. So I think I want to relabel, or if you prefer, like change the letters that we're using. This is describing a sort of pattern. I'm doing this very carefully because people are going to be upset, I think. The fact that I'm aiming for has log base C in 2 places. So I want to write down a true statement that has log base C in 2 places. If I'm doing that, then I suppose I don't really want to use the letter C over here, so I'll do something different for that. But let's try and fill in a true statement where we have C as the base over here and log base A of B as the other fact, as the other logarithm. Yeah. So we could redo the working using letters the other way around, or we could relabel everything. So I want to write down a true statement. The rule is that it's the middle things here that cancel. So I think if I make them the same in my new statement, then they'll still cancel and I'll be left with log base C of B. So I think what I've done is I've changed all the A's to C's, changed all the C's to B's, and changed all the B's to A's all simultaneously, which probably makes people feel uncomfortable. And probably the thing I've just done looks like cheating, because A and B and C, well, a minute ago they had particular meaning, didn't they? We were considering this particular power of A. If you don't like this, you could write out a version here where if you believe A and B and C are already taken, we're using different letters, so sort of D and E and F, and then maybe not E. E is a bit taken, isn't it? M and N and O. Oh no, O is taken as well. Looks like 0. P and Q and R. Yeah, write it out again with P and Q and R, and then hopefully you convince yourself that you can use whatever letters you like, so long as you keep the shape the right. Yeah. Okay. Yeah, now I can divide, because now the new fact I've got lets me just divide by log base C of A to get the thing that I wanted. And C could be anything. It could even be E. So that final fact over there, if you'll let me divide by this and get a fact about log base A of B, is that whenever your calculator needs to do logarithm base A, it can just do natural logarithm of B divided by natural logarithm of A. I don't know if your calculator actually does this or not, but it's an option that your calculator could just work out natural logarithms and a fraction. The people teaching your calculator how to do maths don't have to teach it logarithms other than the natural logarithm. So you have this kind of free will, you can choose whichever logarithm you like, but they're all just transformations of each other. Right, okay. Oh, transformation, right, because we're dividing. So this is, if I replace that for a letter X, then this says that log base A of X is equal to natural logarithm of x divided by natural logarithm of a. I made such a terrible gargling noise in the middle there. Don't clip that. Which says, if you like, just did graph transformations, that you take the graph of natural log of x and you just divide, you just stretch it parallel to the y-axis. Let's give that a go in Desmos. And 2 questions in chat. So the most recent MAT multiple choice questions would be 2024, and we've made the decision not to release the multiple choice questions for MAT 2024. Sorry about that, but we're not releasing them. And MAT is not a calculator test, it's a non-calculator test. Should we test this log fact? Let's test this log fact. So I need y is natural log of x, and y is log base a of x with a slider. I want full screen. There we go. In blue and not one. There we go, that's good. And then the claim is that one of these is just a stretch of the other one. So I'm going to try and do that with natural log of x divided by natural log of a. The question is, have I got the scale factor right to land perfectly on top of the blue line? Looks pretty good to me. Looks pretty good to me. Let's make that a dashed line so that you can see whether they agree or not. So dotty black line for this new ratio which just worked out. Blue line for your favorite base of logarithms. Can we construct it just using natural logarithm and an appropriate scale factor for any value of a? Looks like we can. Oh, even negative, even values less than 1. Let's put some guardrails on that. There we go. Cool. Okay. Can even do E using E. Right. Okay. Is there a proof for why this works? Yeah. Question 19 is a proof for what's going on here. So question 19 is a proof that this works. Oh wow, my camera's really gone, hasn't it? Was anyone going to say that obviously my office is filling with like direct sunlight? There we go. Right, that camera's probably overheating now as well. Okay, right. For those who have just joined and are watching at double speed, it's a very hot day. It's 6 o'clock. The sun is shining directly onto the live stream in Oxford. It's a wonderful time to be doing logarithms. We're about to take a quick break so that I can make sure things aren't going to catch fire in the office. And after the break, we're going to look at some MAT questions. I've got several for you. And we're going to do, I think we're going to try and do all of them. I would normally do a vote, but I think I've got, what have I got? 3, I've got 7, and I've got an hour. We can have a go. We can have a go. Okay, cool. Prove 2 parts, how to prove at the end. So people who want the proof, I think, can look at question 19, and if they don't like the video proof or the video discussion there, they can look at the web solution, the solutions document as well. There are options, right? Right. Yeah, that lighting was quite extreme. I knew I couldn't see anything, but I didn't realise that also the light was going in the camera. Mental, right. Aaron, these are 2 hours long. That's why people watch them at double speed. MAT Livestream goes till 7. Right. Okay. If you've been looking at a screen for the last hour, remember to look away from the screen. Remember that you're human. If it's as hot where you are as it is here, that lighting's all over the place. Let's try and adapt that. If it's as hot where you are as it is here, remember to stay hydrated. Oh my goodness, yeah, I can't do anything about the lighting. It's just going to be a disaster, isn't it? Okay, let's move that way. The lights just moved so that crack in the curtains, just shining directly onto that. Oh, that is a warm camera. Right. Oh, you can see a slightly different angle of my office now. You can see the incredible soft play voice we've got. See my sewing. Okay. This is part of a puzzle. Seven enormous pieces that fit together to make a cube. Oh, I don't know where to sit now. Right, okay, everything's breaking a little bit. Here we go. We've got some multiple choice questions. If I move that, I'm much happier. There we go. We've got some multiple choice questions to do. We're asked about a graph. Earlier, somebody asked me about the graph that's in the thumbnail, and we'll get to that in a second. Here we go. So we've got 5 graphs to choose from, and we're looking for log base 10 of x squared minus 2x plus 2. So this is combining together our skills in quadratics and logarithms and in graph sketching all at once, which is quite a lot, isn't it? What do we think? I think I'd probably approach this by thinking about the quadratic first. Chat, what would you do first? Let's ask chat as well. Most of the options have got, well, large values when x is very positive or very negative, which kind of makes sense because logarithm of something like x squared is going to be very large if x squared is very large, which happens when x is very positive or very negative. So I'm up for that, I suppose, but that's something about all of them. What are the differences between the pictures? Well, some of them have got these turning points, some of them have got these spikes. Some of them meet the axis, some of them cross through the origin. Ooh, crossing through the origin makes me think about x equals 0. That's something I could investigate. And chat wants to do that as well, yes. Find a minimum of the quadratic. Ones that go below the x-axis because, well, I've got to think, because logarithm is allowed to go below the x-axis. That could be a thing. But this quadratic, maybe you know a fact about this quadratic. Look at the turning points, look at the roots. Yes, good stuff. Okay, so I think if you tackle the quadratic first, your life is easier. The quadratic in there, if you complete the square, is something like x minus 1 squared plus 1, which is at least 1 because I've added a square. X minus 1 squared, yeah, plus 1. So it's at least 1, which means that this is once you allow for the logarithm, this is at least as big as 0, and it could be 0 if you put in minus 1. I think minimum of the quadratic. Yeah, I think I'm converging on the approach of chat about thinking about the minimum of the quadratic, except it's at 1, not minus 1, because I said x minus 1. I shouldn't be doing these out loud. Oh, symmetry is a good idea. Complete the square is a very good idea. And Aaron wants to put in x equals 0 and then think a bit about how large is log base 10 of 2. There's a good question in there, isn't there? I don't know if this is intended, but there's a good question in there. Hang on a second. So this intercept, log base 10 of 2, if you put x equals 0 in that expression, so how big is log base 10 of 2? That's a great question. So this would be 10 to the y equals 2, which I don't have much of a sense of how large that is. I suppose I personally know that the square root of 10 is larger than 2. Oh, that's not personal knowledge, is it? You know that as well. Actually, I think the square root of 10 is bigger than 3. So that tells me that this thing is less than a half, because I want a smaller value of y so that I don't get such a large value of 10 to the y. So I think this is less than a half. Does that help me with the question? Can I look at the intercepts and think about whether they're 1 half, less than 1 half, 0, 0, less than 1 half? Okay, that is helpful. I think it eliminates A. Other ways to eliminate A. Yes, so asymmetry is a good idea as well. Although it's hard to judge asymmetry because the axes, we've got a bit lucky that E looks very symmetric in its picture, and that's partly because of the limits of the range there, right? It's what is it? -3 to 4 or something like that. So it's kind of conveniently got. What is it? What is going on with those limits? -3 to 5? Yeah, I think it might be -3 to 5. So that the turning point is right in the middle of the picture. And the other ones have some sort of symmetry. It's just harder to see in these pictures. Like B and D, I think are actually graphs of functions with a vertical line of symmetry, but you can't quite see them. Asymptotes, yeah, so there are values on 2 of these. I guess extension question, not really part of the map, but just for fun. What are the other ones? Shall we have a look at them? Here they are. So I think they're all log base 10 of a quadratic. We could Desmos it. I think C and D are cases where the quadratic just gets to 0 value. And if the quadratic gets to 0 value, then you're feeding 0 into log base 10. And oh dear, that's where it's very negative. But then because it's because the quadratic is just 0 there, it's positive on both sides. So on both sides, you're putting positive numbers into log base 10, which is then returning, okay, very negative numbers, but it's being fine. Okay, yes, you could take the derivative to find the turning points. That does work. If you mean take the derivative of the entire thing, including the logarithm, this is the most recent suggestion in chat, taking the derivative, then I think it's quite hard. It's not impossible. It's one step too many, isn't it? I would just take the derivative of the thing inside the brackets and mumble to myself about logarithm being an increasing function. I would just differentiate the quadratic. In which case it's the same as sort of other people in chat taking complete the square approach. It's one of those times where differentiating the whole thing and trying to use the chain rule or something, you feel very clever because you're using the chain rule, which is once again not on the MAT syllabus, but I'm not sure it gets you much more. Okay. Ooh. Suggestion that we're going to have a suggestion for 1J 2013. I've written it down on a random scrap of paper, so there's no chance that we'll do it. Let's move on to another one. We've got a plan. Neat in chat would like us to do 2013 1J. I do like one. I often like a 1J. Right, here's the one that. So log base x squared plus 2 of 4 minus 5x squared minus 6x cubed. It's famous for being in the thumbnail and for being the one that I always show people at open days. If you come to an open day and I do a MAT talk, there is a good chance that I will show you this logarithm. Here it is again. The question wants us to try and solve this equation. The only way that I know to actually make progress with this is to do x squared plus 2 to the power of both sides, which, the thing I say at the open day, has never been the right thing to do before today and probably won't be the right thing to do any time in the future. But this is about problem solving. This is about doing the right thing for the problem that you're given, whether or not you've seen it before and whether or not you're going to see it again. Which I think for people at the open day is a good message, because MAT's sometimes about doing these things like x squared plus 2 to the power of both sides to get rid of the logarithm. Sometimes it's about doing these things that you never do again. For me, it's the kind of the other way round, right? Because I always do this on the logarithm. I always do this on open days. So for me, it's always the right thing to do x squared plus 2 to the power of both sides. That works in like almost all cases for open day MAT problems. Quite different experiences. I answered that at the open day and gave the ick to a whole seminar, did you? Oh, no. That's not fair. Look, multiple people in chat. Look. We've got Anonymous, Aaron, both came to an open day and solved the logarithms question. It's famous. People have solved it. Good, okay. This 2017 one, down here, we're going to skim past this one, I think. It's carefully designed. It's before my time, but it's carefully designed by somebody to look really horrible, which is why I like it so much. It looks really horrible, but then if you realise that it's a quadratic, so if you start simplifying that first term, until it turns into a quadratic. Then, hooray, you get x squared. You start to think quadratic, and then you start to solve the quadratic, and things only get better from there. The roots of the quadratic turn out to be pretty much things that are printed in the question. So you could use the quadratic formula looking for repeated roots. If you do, be careful, because A is not A, B is not B, and C is not C. Comparing the quadratic formula with the letters in the question. But this quadratic is actually so nice that you can work out the roots and check if there's a repeated root by writing down is the first root that I found equal to the second root that I found. Like, you've literally got them. Because you can factorize it. Once it comes down. I don't know how I would write that in text. Yes, hidden quadratic. Again, which is why I'm keen to skim past this, lest people think that I only talk about hidden quadratics on this show. It's not just hidden quadratics. We also have log facts as well, don't we? Right. Oh, I've done something stupid. Let's see how bad it is. Either that or that's overheated. Okay, right. Everything's fine. Right, if you download the worksheet, then you can work ahead of these, of course, and you also get a whole page of hints, which is a bit like watching the live stream, except you don't get the jokes and the weird lighting effects. Right, so let's scroll through these because I've tried to give you some clues already. Should we do the smallest and largest of these? Yeah, I think I'd like the smallest and largest. The question says smallest, but we're going to do both, I've decided. So let's go over here. Here are four numbers, and you don't need to know how large log base 10 of pi is to do this question. Not to any precision anyway. I suppose you need to know that it's a number. It'd be nice to know whether it's positive or negative. It'd be nice to know whether it's larger than 1 or not. You know some things about this number, but I'd like your strategy, please, if you could let me know in chat. How do you even get started with a question like this? I mean, if you start from the left, you might have to start by trying to evaluate log base 10 of pi, which doesn't seem that fun. Instead, I'd encourage you to read the other options as well and think about comparisons rather than this. Yeah. Here we are, 2008 1B. Yeah, I think we're going to have a quick look at each of these and then have a quick look at 2013 1J if I can get it on screen. That's the plan. We're going to do 7 MAT questions and then an 8th. We kind of skipped over 2 of those just now, but we talked about how to do them. Are we happy? Chat's going to tell me how to do this one. Here we go. Yeah, good. Right, log base 10 of pi. And then square root of log base 10 of pi squared seems even worse. Coincidentally, by the way, I think pi squared is a good approximation to the number 10. I think they're quite close together. So this is probably about 1. I don't think this is how I'm supposed to do the question, but I think this is about 1. The square root of 1 is about 1. If pi squared, like pi is a bit more than 3, so pi squared is a bit more than 9, quite a bit more than 9. About 3.1 squared, 9.61. I don't think this is very helpful though, because I really don't know how large. I suppose that's less than. I'm not loving it. Not loving it. So in chat, people have made the helpful observation that this is log base 10 pi like this. So it's root 2 times the square root of the thing I had before. And in fact, maybe we can get all of these in terms of log base 10 of pi. We could give it a name if you like, but yes. AOL says in chat, if you make it x, then you can find everything in terms of x. Yes. Oh, pi squared is about g from gravitational acceleration. That's a new one for me, Dominic. It's kind of like 9.81. Oh gosh, is that true? Does it get better if you put more digits of pi in? Let me just consider the pi coaster. 3.14. Anyway, never mind. Okay. Let's do what you say in chat and give them names. So in option A, if I call that x, then option B, I have root 2x. Option C, I have x to the minus 3. And option D, I have, what is that? So the square root pi means I can bring out a factor of 1/2. And it's all 1 over that. So I'm going to write 2 over x. If you want me to do more steps on that, sorry, I guess I should have done the square root in slow motion, and then I shouldn't have done 2 steps at once here. But hopefully if you do it yourself, you'll also get 2 over x. Yeah, now people are giving us other approximations in chat. Yeah. Okay. So I want to do some comparisons. I mean, partly I want to put all 4 of these in Desmos and just see which one's largest and smallest. We'll do that at the end. Let's start comparing them. So, question. These two are going to have a fight. X in the red corner. Square root of 2x in the blue corner. Which is larger? So we're talking about a positive number here, so I'm allowed to do stuff like squaring and square rooting. It's all fine. I don't have to worry about my inequality sign too much. So equivalent question is x squared greater than 2x. I shouldn't say equivalent question. I should. For all of this, x is a positive quantity. Is x greater than 2? No, this is nuts, right? So I'm using the fact that x is positive. This step is obviously dubious, right? I have some quadratic going on here. X squared versus 2x. So we'll move it over, x squared minus 2x. I've got 2 roots where these things are equal. But I'm only interested in this bit on the right hand side after 0. I'm kind of being quite rough and ready here because I just need to know which is larger. And the thing is positive, so we're going to be okay. I don't think x is larger than 2 because x is log base 10 of pi. I think it's more like 1/2 than it is like 2. So I think I'm being asked is log base. Look at this sequence of related questions. Is pi greater than 100? So I lied a little bit. When I said you don't need to know anything about the value of pi or the value of 10, that wasn't quite right. It turns out you're expected to know whether or not the circumference of a circle is greater than 100 times its diameter. Pi is about 3, not as large as 4, because circles fit inside squares. Perimeter 3 times the diameter, perimeter 4 times the diameter. Proofs that pi is less than 4. Blink and you miss it. So no is the answer to all of these questions. There was a quadratic in there, wasn't there, for a second? Yes. Okay. Sign in chat, that gets on screen. I think that's great. I just approximated. Pi equals 3 and 10 equals 9. Which, the first one was quite respectable. The second one, ooh, psychic damage. Right, okay. If you do that, then I suppose you get the first one. The first one is log base 9 of 3, which is about 1/2, because 9 to the 1/2 is 3. And the second one is about 1. So it's not close, is it? Okay, are we being asked for the smallest? We're being asked for the smallest. Okay, you can do similar comparisons on the others. And since I'm being asked for the smallest, at the moment that's x. X has won this fight. And I should now go and compare it to the other ones. I think you can get away with the same comparisons. For this one, we'll need to know whether x is greater than 1, and Again, no. This time I'm being asked, is log base 10 of pi greater than 1? And the answer is no, because this says, is pi greater than 10, which is closer but still no. Scribbling away. Yeah, x is less than 1 seems to be enough information to get through quite a lot of this, doesn't it? The comparison between pi and 10 seems to be a crucial thing going on here. That wasn't obvious to me from the get-go. But x is, this thing on the left is still small. Last one then, is x greater than 2 over x? Is x squared greater than 2? Oh, that's a bit better, isn't it? Oh, is x greater than root 2? Well, no, because x is less than 1. So, okay, fine. Out of all of these things, the smallest one is, I think, the first one we saw. Let me double check that I haven't done anything stupid. Yeah, that's the first one we saw. And in fact, I think I want to know, the comparisons felt like they were, the stupidest one was the left one, the very first one we saw. So I wonder whether it's the case that that's the function. That's the function that's kind of the largest. Let's find out. I think it probably is. So we have things like this. And finally, things like this. With these kind of 4 curves going on. And what were we asked? Smallest, and the number is less than 1. So we're in the range over here where the number we've got is less than 1. Should I put in x equals log base 10 of pi? That's our number, isn't it? And as you read upwards, you see the red line, that one's the smallest. Then the blue one was the next smallest, so I was wrong. And then the purple one, and then the green one. So the thing, why was I wrong? Learning moment. The sequence of the intersections, so the intersection here, where are these equal? That intersection point is really far over there, but that's got nothing to do with whether the function is large over here or not. Okay, so the crossing point for these ones is at 2, whereas that for these ones it's at 1 and square root of 2. But that doesn't mean, that doesn't tell me which one's the largest, because they're just going in completely different directions. Okay, good, right, cool. So for log base 10 of pi, it turns out, in fact, I'm not sure we've done enough maths to work this out yet, but 1 over x cubed is the largest. I don't think we compare to the green and purple. Let's do that very quickly. If we just want the largest. Is 2 less than x to the minus 2? Is x greater than 1 over root 2? Oh, that's a bit harder, isn't it? That's quite a lot harder. That crossover to decide which of those is larger. Don't know how I do that. Yeah, okay. Chat was having a bit of a vote while I wasn't looking. C is very big. It's not obvious whether C or D is going to be the largest, I think. Did I close the decimals window? I did not. There we go. Let's quick look at my setup of all of the many things my computer's trying to do. Because if I have something like this, have a slider? Never mind. If I have this slightly to the right, there's this crossover point between the green and purple lines at 1 over root 2. And it's not obvious to me immediately whether this log base 10 of pi is greater than or less than 1 over root 2. 1 over root 2 is about 0.7, this thing's about 0.5, so pretty close together. So this question seems to be hard. Is log base 10 of pi greater than 1 over root 2? The answer is, I think, no, but I think that's a fair bit harder. Because squaring both sides, I don't know any nice rules about the square of a logarithm. There you go. Using 10 equals 9, you can approximate all of these things. Good tactic, I like it. Yes, and if you've approximated log base 10 of pi to a half, which is about the same thing, as the other approximations people are doing in chat, then it becomes clear which one you want. The problem is I might also approximate, so this is about 1/2, but there you're using quite is it so close to 1/2 that you're sure it's smaller than 0.7? I don't know. How good's your approximation when you replace 9 with 8? No, 10 with 9 and pi with 3. How good's your approximation? Are you sure it's still smaller than 0.7? There's only a little bit of error there. Not obvious to me, I think. Although we did just look on a calculator and the calculator said it was true, so maybe I should just move on. Yeah, I don't know what I would do here. How would I work out 10 to the power of 0.7? Because that seems like a split point. Can I do 10 to the 0.7? 10 to the 7/10? Okay, so 10 to the 10 versus pi to the 10. Yeah, is pi to the 10 greater than 10 million? I don't know. I don't know. Okay, right. I've invented an extension that's too hard. As a pure math student, what do you think of 10 equals 9? She replies, Callie has been losing their mind for the past 10 minutes. Sorry, Callie, we're moving on. you really, joking aside, you really can't take 10 equals 9. I mean, you can, it's a multiple choice question, you can do what you like, but I'm trying to encourage people to be careful as well. That last one, the 10 equals 9, people have got a pretty strong answer that was actually correct. Pretty strong belief that was correct, but this sort of thing where you have a small approximation and then you start applying functions can get really out of hand. If your function stretches things apart, if it has a very steep gradient, then putting two very similar numbers in, like 9 and 10, might give you very different outputs, so that although 9 and 10 are very close together as numbers, if you put them into the function x to the 4, then you get very different outputs. 9 to the 4 and 10 to the 4 are totally different, and not just by like one's 90% of the other, one of them's really small, like 60% of the other. Right, okay. Will there be Q&A at the end? Maybe, who knows? There's kind of Q&A all the way through all the time, right? If you want to ask a question and you don't want to wait for a break, or you always have the option to contact us. We have an email address in the YouTube description or on almost all of our pages on the maths website, which is, it's quite hard to say out loud, it is undergraduate.admissions@maths.ox.ac.uk. That goes to my team to answer questions about admissions. 3 to go, half an hour, and then a bonus one, because there was a request in chat for a bonus one. We're asked for a high power of x in here. This question, I'm quite fond of it, because you might want to work out all of the terms. I don't think anybody really wants to work out all of the terms. Surely, if your plan is to work out all of the terms, surely you'll lose patience before you've worked out really any of the terms. You might work out that cube on the left and then think, no thanks. Which is maybe helpful because you've got a power of x to the 18 in there. You look at the next one and you think, wait a minute, this 3x to the 8 and 12, fine, to the power of 4, that's going to give me an x to the 32. I'm way more interested in x to the 32 than I am in x to the power of 18, so I should try and avoid working out coefficients or working out low powers of x if I could be working out high powers of x. So just to label this, I'm suggesting that the way you make progress with this question might be that you multiply this out. Oh my goodness, why did I start doing this? I just said it was a bad idea. Oh, I didn't quite say it was a bad idea, did I? So you might start multiplying it out and realise that you get the power of x to the 18, and then look at the next one and think, so the first thing I'm going to get is 3 to the 4 x to the 32, and then all of the other terms have got fewer x's than that. So A, I've realised that I don't want to work out all the rest of the stuff. And B, I've realised that sometimes I don't want to work out an entire bracket. So when I look at the other ones, I'm just going to think about powers. So I see, oh, sorry for shaking the screen, 3x to the 5 to the 5 gives x to the 25, gives x to the 25. But do I care? Because the other one, x to the 7, oh, sorry for the screen again, x to the 7 plus dot 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 for the 6 here, to the 4, that gives me x to the 28 plus some other stuff. So I don't care about any of the terms in this bracket. And you can do something similar to work out which ones you care about and which ones you don't care about. Yeah, so kill the constants. The question also doesn't ask for the coefficient out the front. So I shouldn't really be working out these things like 3 to the 4 or 343. Like it's cool that I know the cube of 7. I get to say that's cute. I get to say that's cool. It's cool that I know the cube of 7, but I'm not getting any marks for it because it's completely irrelevant down here. I'm asked for high powers of x, not the constant on the end is 343. Nobody asked. Also, good reaction to anybody who knows the cube of 7. Nah, knowing the cube of 7 is cool. Yeah, so sort of ignore the coefficients, ignore the constant terms, or the things you don't care about. Oh, I guess people are saying constant terms because they want to ignore the plus 7, the minus 12, and the plus 6. You can also ignore that minus 12x squared in the middle. Or if you prefer, the thing that you're doing is bringing out a factor of x squared to the power of 5 and then ignoring a constant that says minus 12. You get that bracket, the kind of third bit out of 4, that third quarter, is different in a way that you could bring out some factors of x from that one first, if you really wanted to. You don't have to. Yes. You immediately rule out, Rosie wants to rule out A's and C's because Rosie is starting from the outside. These curly brackets, the whole thing is cubed. So the top power is going to be multiplied by 3. So we should pick something that's a multiple of 3. Good shout. I like that a lot. That eliminates two things, which back in 2008 would be enough to get you probabilistically half marks. You don't really get half marks on a multiple choice question. You get is binary. You either get the marks or you don't. But if you can eliminate half the options and then guess, then probability, you get half marks, right? So in chat, on screen, in chat, Rosie's ruled out 2 options to get B or D. Now look, K above knows that it's D, so K is going to get the mark. But even if Rosie doesn't want to do the rest of the maths, Rosie can get probabilistically half the credit. People sometimes ask me if you get partial credit for multiple choice questions, and the answer is no. But if you've got questions you can't do, but you can make a partial guess, then overall your expected value is some marks, right? Okay. Rosie, I'm not saying that you should guess, by the way. I think you should look at the rest of the question, and indeed, I imagine that while I've been waffling away, you've probably done the rest of the question. Good. I could work out minus 12x squared. Could it minus 12x squared? Because it could have a coefficient. You would work out minus 12x squared. It could have a coefficient exactly equal to the highest power. Okay, so this person's got a good concern. They're worried about minus signs. I think there's a possibility that we get 2 terms coming from different places that have the same power of x and that cancel each other out perfectly. If you like, this could be, even with the plus sign, this could be a big disguise for something like this. So that when you add them together, you think, aha, 301, 301, but no, they cancel, and you're left with something like x to the 300 or something else. That doesn't happen in this question, and I'm still not worried about the minus 12x squared in particular. Minus 12x squared in particular, because that x squared is such a low power of x that it's not going to cancel things like 3x to the 5. The thing to worry about here would be if the leading powers cancel. So you're right, we should worry about this a little bit, that if it's a tie, then that tie might lead to mutually assured destruction, where we lose all of the terms of that power. But in fact, the highest power only comes from one place. So although we're not tracking 3 to the power of 4 to the power of 5 or whatever it is, it's just a single very large number. So no possibility for cancellation. You're correct that this is something we should worry about in general for questions a bit like this, where there's 2 large polynomials being added together and you're asked for the degree. Like, it might cancel. They might both be quadratics, but that doesn't mean that the sum is a quadratic. Cool. So in 2008, I said specifically half the credit because there are 4 options there, and Rosie had eliminated 2 of them. Since 2014 or something like that, roughly 2014, there have been 5 options to make guessing slightly less good, broadly speaking. And yes, Oxford is just for the MAT. No, MAT is just for Oxford in 2025, so everyone who's taking it is applying to Oxford. You can't do it for fun. And some people in chat just sort of winced at the idea of doing this test for fun, but here we are. Okay, we've got 2 to look at. Main powers. So that the main powers we have to deal with do not have any negative signs. So, okay. Yeah. You can also be saved by even powers, right? So if you see a negative sign, but there's an even power that you're raising thing to, then happy days, that'll become a positive number, which might reduce its ability to cancel. Speaking in very vague terms, you can do the TMUA for fun, TMUA for fun. We've got largest of these 4 numbers. Here, it's a good idea to get a grasp of how large the numbers are, I think. Are they greater than 1? Are they less than 1? Are they equal to 1? I'm looking at the options to see if they've set anywhere the base is the same as the number. They haven't. But I do notice that we've got log base 2 of 3 and log base 3 of 2. It just can't be the case that both of these are greater than 1. Because of how powers work, that if the power, so the left one is telling a story about what you need to raise 2 to the power of to get 3, and the right hand one is telling a story about what you need to raise 3 to the power of to get 2. Those are kind of inverses, I suppose, in a very real sense, but they're inverses in my head, in the sense that if you raise 2 to a power that's larger than 1, and then you raise that to a power that's larger than 1, then you'll get something much larger. You won't get back to where you started. I realise now that using the rules we've seen, these are reciprocals, aren't they? They're just the other way up of each other. So their product is equal to 1. Cool. Wait. No, I said math. This one say math. To be clear, as the thing I said was that if you want to do the MAT, M-A-T, this test that we're talking about, you have to apply to Oxford, which, to be honest, normally goes the other way around. People want to apply to Oxford, so they do the maths admissions test. You're now talking about Cambridge, and you should look up the admissions process for Cambridge on the Cambridge website. I think they use STEP for maths, and yes, they do maths. Right, okay, so these things made me suspicious, and then in between them, I see there's log base 4 of 8. I've got opinions about this, because I know what you have to raise 4 to get 8. 4 to the x equals 8. I have feelings about this, right? This is 2 to the 2x equals 2 cubed, so I think x is 3 over 2 for the power. How many 4s do you need to multiply together to get 8? Yeah, no, 1.5. That's how many 4s you need to multiply together in order to get 8. Not one of them, that's not enough. 2 is too many, whoa, that would be 16. Yeah, no, between 1.5. That's very confusing thing to say because, of course, half of 4 is 2, and that's misleading. Oh, I should do a different example now, just to point out that, oh no, here we go. That's an example of me doing a joke and then realising it's quite bad for you. How many 9s do you need to multiply together to get 27? Oh, 1.5. Not 1, that would just be 9. Not 2, that would be 81. 1.5 of these 9s, multiply those together. That'll give you 27, just fine. See, I have to avoid, because half of 4 really is 2, whereas I mean half in a silly logarithms way. So I have to not confuse you with the normal meaning of the word half and the silly meaning of the word half. Otherwise, it's a joke, but also misinformation. Fine line. Right, okay. So I get the impression one of these is greater than 1, the other one is less than 1. Which one is it? This one is greater than 1. That's a good start. Is it as large as 3 over 2? And is the other one as large as 3 over 2? Well, we can do some comparisons, can't we? And if you do some comparisons to say, well, I like to phrase them like this: is log base 2 of 3 greater than 3 over 2? And let's find out by doing things like 2 to the power of both sides. Is 3 greater than 2 to the 3 over 2? Is 3 greater than 2 root 2? I don't know. Let's try squaring both sides. Is 9 greater than 2 cubed? Oh, yes. 2 cubed is 8. So that first thing is larger than 3 over 2. And then the others will turn out to be smaller than 3 over 2. And one more comparison question to wrap things up. Yes. Yeah, simplifying one of them was a good method. I thought I'd talk about the A and C first, but that simplifying B, if the base and the power are closely related, like if they're both powers of some number, I'll write this down because it's what I've got in my head, but if they're both powers of some number, this is awful. This is really bad. This is terrible. If they're both powers of some number, then you can probably do something there. It's worked twice. You can probably do something with this. You can probably simplify that. I've gone very nervous because of how bad that looks. That looks really scary, but I reckon you can deal with it. What do you raise a to the b to the power of if you want to get a to the c? What do? You've got a to the b in your base. You've got to raise that to some power, and you want to get a to the c. What's the right power? Yeah, so the answer was, for that one, A, I think, for that last one. Or maybe K is now answering this new one with logarithms of things. Oh, I'm quite pleased with that. That looks awful, but I reckon it's got a simple answer. Can chat tell me? I think that simplifies really nicely. Chat's on screen. Here's your chance. Yeah, that's power you'd raise it to, right? Yeah. If you want the questions that are on screen at the top, the PDF of questions is available on the MAT Livestream website, which you can also find in the YouTube description or by googling MAT Livestream. It's got not just this worksheet, but the 4 previous worksheets and the 3 future worksheets that we'll be looking at, along with full solutions. And if you print all of them and stack them together, it looks a bit like a book. I should write the front bit of the book. There should be a front bit of the book, right, which tells you this book was written to help you with the math. I don't know. Yeah, I'd raise it to C over B. Yeah, good. Okay. So I think this is equal to C over B. And doesn't that look horrible? I think you're just sort of cancelling the A's out of this. I'll draw my fraction better for the screenshot. Okay, there you go. Good job, chat. I think we've invented a new law of logarithms. Log base 9 of 27. Well, that's 3 squared and that's 3 cubed, so it's 3 over 2. Just simplifies. Nice. Right. In before someone says, do I have to memorise that fact we just invented on the live stream for the mat? No, you'd have to memorise it. Okay, right. We've got one more. Chat's going to vanish, so we can look at option D, just in case it's option D. We're asked which of these is the smallest. And some of them are easier to simplify than others, right? So we've got like sine 60 is the one that jumps out to me as one that I should be able to simplify. Oh, I'm a bit rusty on these, aren't I? There we go. There's a stream about trigonometry coming up, so I'll have to get really good before that happens. I think I've done true maths there. Somebody in chat's going to correct me. Oh yes, I never showed you why log base 2 of 3 is bigger than log base 5 of 10. Oh, was I wrong? So log base 2 of 3 is bigger than 1/2. It's bigger than 3 over 2. So log base 2 of 3 is bigger. I should also convince you that log base 5 of 10, log base 5 of 10 is not bigger than 3 over 2. It's smaller than 3 over 2, and in fact smaller than, therefore smaller than this thing as well. I didn't do it on screen, sorry, that's an oversight. So this bit is asking, is 10 greater than 5 to the 3 over 2, which is a bit like asking, is 100 greater than 125, to which the answer is no. Messing around with some powers and some rearranging. So that one's smaller than 3 over 2, this one's bigger than 3 over 2, that one is 3 over 2. So and the other one is really tiny, it's smaller than 2 over 3. I've had a thought, never mind, okay, good. Sorry, I didn't finish the previous question, you're right. Ruben in chat is using other laws of logarithms to prove our new laws of logarithms. It's the most sort of theory building thing that you could do with the available information. Right, okay, let's look at the logarithms ones. We've got a couple. We've got a chance to use our new fact. Oh, it's not even using our new fact, is it? Because this is just log base 3 of 3 to the base. That's a real math question. Yes, it's a real math question. That's just 4, isn't it? That's just 4. And this thing's larger than 6, so because it's 6 3/4. So what's going on with this question? It really is just 4. So they look horrible, but you can simplify them just straight away. So the mysteries left to me are, how big is root 3 cubed? Is it, for example, as large as 4? It's 3 root 3. So is 3 root 3 larger than 4? I want the largest? No, I want the smallest. Well, let's fight them this way around anyway. Is 27 greater than 16? Yes. So smallest is currently looking like 4. It's certainly smaller than 6 3/4. And then we've got this one over here, where we've got these powers of these logarithms base 2, and I've got not 85, whoops, not 85, but 8 to the power of 5. Oh, so that's pretty fine as well, isn't it? That's log base 2 of 2 cubed to the 5 is 2 to the 15. So I want to compare this with 4, because 4 is currently my smallest number, and this looks like, hang on a minute, what have 2 and 4 and 16 got to do with each other? Well, I think 16 is, and 15, 16, God, this thing would be 4, because 2, 4, 8, 16, 2 to the power of 4 is 16. So I think log base 2 of 15 is less than 4. So I think it's the smallest. That was quite straightforward, wasn't it? Okay, good. Right, this has given us 5 minutes to look at that question we had a request for. 8 to the 5 is not 85. Thank you, Dominic, in chat. I don't know why I did that. Have I told people recently that my in my interview, the mistake that I remember making is that I had 5 to the power of 4 divided by 6 to the power of 4 as a fraction. It was a probability question, and I simplified that by crossing out the 4s. You know, you do the same thing to the top and bottom of the fraction, right? And I did that in my interview and still got in, so everything was okay in the end. Because it was an interview, which meant that they could say, no, I don't think that's right. I don't think you mean that. Rewind, and now have another go. And you go, oh yeah, whoops, don't know what I was thinking. But occasionally I make a mistake like that, and I think, huh, yeah, what am I like? Interviews are good because the interviewers can help rewind and fix things and spot things while they're going wrong. So it's quite a bad mistake. But occasionally, you know, like I write 85 instead of 8 to the power of 5, and I think, oh, powers are tricky. Welcome to the MAT Livestream. Powers are tricky. We've got a request for a question. This one hasn't impressed me very much. Sorry, I know I put it here, but we simplify things too quickly. Not hard enough. We've got a request for a question, and I've got a minute, so let's have a quick look together at what you can find on the MAT website. Maybe this is a chance for me to mention the MAT Livestream page again. Have I mentioned it? I think I've mentioned it. Let's just check. So there's this thing called the MAT Livestream website. It's great, if I say so myself. it has got, for example, a link to watch the live stream, which is where we are, and access chat, which is where you are. It's using the future tense here, but it shouldn't because we've already started. Whoops. And you can get worksheets for geometry, trigonometry, and sequences and series. Sequences and series, in particular, is the thing that people sometimes haven't seen yet. So if you want a sneak preview of some sequences and series content that you might be about to learn in school, that might be that. But it's part of a wider bit of support for the maths admissions test. And there's a link here as well for the maths admissions test, the page with the coffee cup, which has got lots of past papers. Now we've got a request in chat for 2013 question 1J. So I go in here, I can go down to 1J. Right, yeah, it does have a logarithm in it, so it's on topic. Let's see if I can get this a bit larger. How am I going to do this? I think I will... 5 minutes? 5 minutes, right, okay, I'm going to download it and throw it up on the big screen. So can I do that? Does that work? If I drag it here? Yes, but it takes away all of my controls. Right, put everything back, put everything back. Oh, panic. Close all the Desmos charts, they're making everything too slow. Close all the Desmos. Close all the Desmos. Close that one as well. I think we've got, okay, and then split. We've got mat test. Close all the stupid PDF tabs that open whenever you open a PDF. Scroll down 2013 1J. It's a perfect live stream. All the tech works absolutely perfectly every time. I've minimized all of my controls again. Chat's broken. Oh, the things we do. Right, okay, here we are. Take a screenshot and press paste. That would have been so much better. Oh, can I get Anonymous to run the stream? Right, too late now. But look, now I've got my perfect setup with my split screen. What's this last thing at the bottom? It says that's the power. Or it's not a perfect system because I need to be able to read the question. I'm pretty sure I know what the question is. We have got the integral from 0 to n, here we go, and then there's this floor function thing that I've seen defined in a few past math questions, where the idea is that we take a 2 to the x and we round it down. We take the largest integer that is less than or equal to that thing. So if I draw a graph of 2 to the x, it looks like this, from 0 to n, but then we're supposed to round it down. So the question is, and this will be, I think, the whole question, where are these steps? Where does it change value? So we're rounding down to an integer, so if I put in 0, the function inside will be 1, and then at some point the value will get large enough that the rounding down will round down to 2 instead. And if we can understand when, then the question becomes easy, because the question becomes all about adding together the areas of these rectangles. Integration means area under the curve. So if I can work out where it changes value, I can split it into what it really is a whole stack of rectangles next to each other. So that's my plan. If I can work out where it changes value, then I've got the widths of some rectangles. The heights are the numbers 1, 2, 3, 4, 5, up to, what is this going to be? So when you put in n, the very last thing that I see is 2 to the n. So very briefly, 2 to the n rounds down to 2 to the n. But I think there's a step here. So it's only if I put in exactly n. If I'm slightly below n, then I get slightly below 2 to the n and I round down. So I think this last bar is actually at 2 to the n minus 1. So I'm like out by 1 error here, where literally putting in the value n gives me 2 to the n, which fair play rounds down to 2 to the n. You made it just to the value 2 to the n, but slightly below n, down to some mystery number that I haven't worked out yet. We get this very tall rectangle of height 2 to the n minus 1. Why doesn't the question use proper floor notation? Yeah, it's got these square brackets in, hasn't it? I don't know. I have a suspicion, but I'm not going to say it out loud. Yeah, good. Anonymous says, do we need to know about it? I've heard about it a few times, but not learned what it is. Two things to say to that. One, no. It might be defined in future questions. It's been defined in past questions, so it might be defined in future questions. But every time I've seen it in a question, it's been defined, which means you don't need to learn that it is the largest integer less than or equal to x. Second thing to say is, I think you have now learned it. Yeah. So sort of, sorry, but too late, you've already learned it. Oh, Rosie wants to set n to a low number like 2 and then just go for it. That's a great idea. Let's set n to 2. Yeah, okay. Yeah, I think that's the energy level I'm at as well. It's 7 PM, so I want to get an answer. Let's set n to 2 and draw the picture. So 0, 1, 1. We get some value. Oh, I've drawn these like they're the cutoff points, but that's not quite right, is it? They're points where I know the value. 2 to the 1 is 2. 2 to the 0 is 1, 2 to the 2 is 4, but we're rounding down, so for a while over here, things will round down. Oh, it's between 1 and 2. The values of 2 to the x are between 1 and 2, so they'll get rounded down, different colour maybe, they'll get rounded down to 1 until we get to input 1. Ooh, I have an axis down here. And then the question is, when do they get rounded down to 2, and when do they get rounded down to 3? Where's the split? And the split is when, question here, when is 2 to the x equal to 3? And that's a logarithm question. That's x is log base 2 of 3. That's this point here. Okay, so the widths of my rectangles are 1, this thing minus 1, and then 2 minus this thing. So the area under the curve, the integral, is 1 times the height of 1 plus, oh my goodness, log base 2 of 3 minus 1 times 2, the height of 2, for that bit where it gets up to 2, plus 2 minus log base 2 of 3 times 3, for the height of 3. And that does simplify, but it's a bit tricky to simplify, isn't it? And really I should be doing this up to n. This pattern continues, especially if you realise that this number 2 here is log base 2 of 4. It's the next thing, and this 1 is log base 2 of 2. So there's actually a nicer pattern going on that maybe you can generalise. Maybe you can notice that we have log base 2 of, can I get this right? What do I want to write? I'm going to write log base 2 of 2 minus log base 2 of 1. That's a bit silly, but I'm going to roll with it. See what happens. Log base 2 of 3 minus log base 2 of 2 times 2 plus log base 2 of 4 minus log base 2 of 3 times 3 plus dot dot dot. And there's a last term at the end here. I know it looks a bit silly. When I'm hoping this will simplify, so it helps to make the terms more similar, which means I'm unsimplifying particular things like this thing, partly because of how it generalizes, but partly because I want these things to fit together. Sorry about that. So in particular, this last thing I'm going to simplify as the last width is this. I know really this is n for the final x coordinate minus, it looks like we're using one number at a time, so this times that final height, and the final height is, the rule is it always matches that last thing, 2 to the n minus 1. The question is now, can I simplify all of that? And that's not easy at all. I've had to back away from it to give it a huge amount of space. Possibly I like Rosie's idea, which is still happening in chat, that I should just stop after this term and simplify and compare the options. But you know, you can look in chat if you want to see Rosie's calculation, or you can simplify those first 3 terms. You simplify to here, sorry, first 3 terms for n equals 2 and compare. I feel like I should probably do the whole thing. Yeah, I should probably do the whole thing. So in each case, almost everything appears in a bracket with a plus sign and in a bracket with a minus sign. which means that almost everything does some cancellation, right? So how many log base 2 of 4s have I got? Well, I've got 3 of them here, but I'm about to subtract 4 of them. So they're kind of all going to be subtracted. That's a lot of subtraction. When the dust settles, the first time in each bracket is going to cancel with the thing with the minus sign in the next bracket, which will leave me, well, not quite cancel because the coefficient goes up each time, which will leave me with this thing at the front. I haven't got anything to cancel that with, minus a whole load of terms. Log base 2 of 2, log base 2 of 3, log base 2 of 4, because each time the subtracted term comes in the next bracket along with a larger number. So this minus log base 2 of 3 is here times 3, and it's here times 2. So I get one left over with a minus sign at the front. Subtract everything, even this log base 2 of 2 to the n minus 1. But then I'm left with, at the end, this thing. That wins. There's no further term to cancel anything with. I hope this simplifies quite a lot. Sorry for shaking the board. Okay. What have I got then? This thing, I included it for the pattern reasons, but it is 0, so that can go away. This was 1 minus 0. I just thought it would be neater to have 2 sorts of logarithm in each bracket. I don't know. That's 0. Maybe that was a waste of my time writing that out. This looks like log base 2 of 2 to the n minus 1 factorial. And I also have this log base 2 of 2 to the n. I'm going to write that as n again, times 2 to the n minus 1. Am I close to any of the terms on screen? Kind of close. I've got an n2 to the n, and I've got minus quite a lot of stuff, so I am looking at b. B says that I should have n2 to the n first, and then I've got minus 2. So I'm aiming for the thing in the question, but discipline, I have to write down something that's true. So I have to write down what I've actually got, which means minus n. Can I find a reason to make that into b? Yes, I can, because the difference is just that this would also have, if it were log of 2 to the n factorial, it would have an extra 2 to the n in here, which is n. Phew! Okay, it's b at the end. And that simplification involves something that's called, in general, a telescoping sum, where things cancel, and it's not the easiest sort of telescoping sum. So telescoping sum often has sort of circle minus triangle. This is the kind of shape that I'm talking about. Triangle minus square, plus square minus hexagon, plus, and then hexagon minus star. And the telescoping sum thing is that if the thing you're subtracting is then added again in each case, then this all telescopes down like one of those collapsible telescopes, and to give you circle minus star, because everything else cancels out. This is not quite that, because we have extra terms of times 2, times 3, times 4. So the version here is something like, well, you still got this circle that's not cancelling with anything, but you're going to lose 4 times the star at the end, and also everything that was cancelling, actually there was slightly more subtraction, so subtraction of everything else. Subtract a triangle and a square and a hexagon. They haven't cancelled perfectly. There's one more in the subtraction pile. Okay, what does chat say? We're going to go into a kind of chat mode now, I think. I think that's all the math questions I'm going to look at today. Yes. You're welcome to hang around. There might be some questions. The questions might be about questions, but I think that's all the math questions. So if you're leaving now, thanks for joining in with MAT Livestream. Next week, it's either geometry or trigonometry. I had it on screen a moment ago and I've forgotten. Yep, no, lost it. It was either geometry or trigonometry. I want to know now. Geometry first. So if you want to see some circle facts, we'll be live next week. See you in 166 hours for another episode of the MAT Livestream. But I'm going to hang around and answer things like Kay's question here. Should we remember the method to integrate this function? To which I'm going to say a version of yes, because what we've really done is to combine together ideas about integration being the area under a curve and That's easy if the function is straight line, or if it's made of lots of different straight lines. You can use rectangles and squares and things like that to work out the area in that case. And the thing that's really going on here is quite a weird description of a function, but not so weird that we can't talk about the area. So things under the curve. You could probably do a version of this where, you know, a floor function has turned up a few times, but maybe you could have some weird function which was defined as sort of like x or something. What do I want? I want something that's kind of triangle shaped, so that then you end up with lots of trapezium stuff. I don't quite know what I'm doing here. Am I writing a math question live on the stream? Would that be a good idea? Probably not. So you'd have some like weird function. I haven't quite worked out how it works yet, but it would take something like 2 to the x or maybe sine or something, and convert it into lots of straight line segments, but an angle, so that you have to use trapeziums. And then people say, oh, I've learned the trapezium rule and I haven't learned the trapezium rule, so it's not really fair. Because some people know about trapeziums. I can't even spell trapezium today. Maybe that would be fun. Maybe it wouldn't be that fun. Right, thanks everyone. If anyone wants to hang around and ask questions that you didn't ask at the open day, you're welcome to do that. If you're coming to Unique next week, you're welcome to catch me at Unique next week. It's part of the idea of Unique. And otherwise, I'll give them a minute, but otherwise, I think I'm wrapping up. Next week, Georgia. I survived. The office didn't get any hotter than it did at 6 o'clock. 6 o'clock was the worst bit. 6 o'clock was pretty bad. Hey, Anonymous is going to see me at Unique. Hooray. Right, okay. Either somebody's typing a long question, which they should be allowed to. Okay. Bye Crunchy bye Aaron, bye Anonymous, bye Grace. Good, right, okay, I'm going to pack up a little bit. I'll try and be useful at the same time. Yeah, I really do like logarithms. They're sort of one of those things that you genuinely, in the UK at least, I think you genuinely meet them for the first time at A-level. In a world where you've seen a lot of stuff like algebra and multiplication and circles and trigonometry a bit, you've seen at GCSE, logarithms are kind of a genuinely new topic. They're kind of genuinely A-level, I think. I have Q chat telling me you see them at GCSE. Right, I think people have asked the questions that they want to ask, so I'm going to leave it for my team on emails. So you see some of you, 4 days. Oh gosh, yeah, okay. See you Monday. See you Monday for that summer school, and I'll see the rest of you Thursday again for MAT Livestream. Oh, look, I know one more. Do you want to mention any clubs or workshops that I've done? Yeah, if they're relevant to your degree that you're applying for, and you think they're useful preparation for university, if they're related, then I think that's one of the questions is, what are you doing outside the classroom that's helpful? Something like that. Yeah, you're welcome to talk about that. You don't have to. If you've got so much purely academic stuff that you want to just talk about purely academic stuff, then I don't think you're required to do stuff outside of studying courses and getting grades. But good to hear that you're doing other stuff as well. And Hector wants to ask about personal statements. For maths, it's hard to say what we've done after the reading of books, because usually it means what we're reading. Sometimes it means you tried a problem if there are any questions in the book or like an exercise, and sometimes it means you kind of made up your own problem or thought. So sometimes I read like an Enrich activity, and Enrich is this website full of activities, and it's not hard enough, so I need to think of a harder activity. And that sort of idea is, I think you can apply it to other stuff like YouTube as well. So if you watch a YouTube video and they do some questions, and the questions are not hard enough for you, you probably make up your own questions. It's also probably true if you watch a YouTube video and they tell you like, the Riemann hypothesis kind of says X, and you go, oh, tell me what it really says, and then you go and look it up. So it is reading related to reading or watching, but there's something a bit more active about selecting what you're going to go and read or why you want to read it. And what you got out of reading is I went and looked up the proper definition of the Riemann hypothesis, and it's really hard, and I didn't understand any of the words. So I went to a maths dictionary online, and I looked up the meaning of some of the words, and they're all very hard. And I realise now that I need to do maths at university for 3 years to understand about analytic functions before I can understand properties of that one. Possibly, who knows? That is neither a guarantee that you need to do 3 years of analytic functions in order to prove the Riemann hypothesis, nor a claim that you can't prove the Riemann hypothesis without doing it. I'm claiming neither a necessary nor sufficient condition to bring us full circle. Right. Other books. Other books like Science and Technology much harder because might or might not be related to what you want. I think that shouldn't stop you from reading stuff. I think reading other stuff is just good for you. That's not admissions advice. That's just personal advice. That reading wide is probably good. I don't know if it helps you for university, but I sort of think that some of your reading shouldn't be helpful for university, if that makes sense. And there's a contradiction in terms, right? Because this is MAT Livestream. I'm the admissions coordinator. Kind of everything I say is admissions advice by definition, isn't it? But kind of like, if you want to read other stuff, that's probably helpful. Can I do the MAT without applying to Oxford? No, sorry. The MAT is only for Oxford applicants this year in 2025. Right. And then do I recommend any other books for MAT preparation? Not really. Sorry. I think you asked this before. Somebody asked this before. What books can I prefer for MAT? Well, there's this one that we're working through, which is made of PDFs on the web. There are other ones out there. I don't prefer them, but that's my personal preference, I suppose. Right, okay. I'm going to call it there and see you for another episode of MAT Livestream. 5 o'clock next Thursday. Geometry time. Hooray. Right. Bye.